Welcome to part 2. This episode of On the Bridge, we are going to explore a much debated and potentially transformative idea in super yachts, nuclear propulsion. Not theory, but real discussions about whether nuclear could power the next generation of yachts and what that means for owners, builders, and the wider industry. I'm joined by Derek Munro from NOxFree, Ben Geary from Döhle Yacht Management, and Jez Sims from Lloyd's Register. I hope you enjoy part 2 of this podcast. Okay, this is a question for all of you, really. I'm going to be Joe Public. When people hear nuclear, safety is probably their first concern. How do you address that in practical terms? And what I mean by that is, I think we mentioned it before we started recording, that nuclear sort of is a bit of a sort of scary word to most normal people who aren't, au fait with the subjects we're talking about. How would it work having nuclear on a boat? Just how we talked about earlier, engineers, who's looking after it? How is it stored? Would just give me a little rundown of.
So the intention at the moment is that the nuclear unit will be put into a sealed off space on board the boat, that you could, because it doesn't need lots of air and everything like an engine does, you could just seal off a solid compartment, maybe have an inspection hatch that they open once a year or every 6 months and popped in just to make sure the silver's still nice and shiny. But essentially they don't touch it.
Okay.
Engineers do not have to be specially trained. Most engineers now on a yacht are qualified enough that they can service and look after a turbine and the other side of it, the power generation side of it.
Right.
So their qualifications should cover all of that anyway. The crew will potentially never see it, depending on whether they're there when it's loaded on and taken off. From a safeguarding point of view, the lease holder is going to have to be able to prove that it's all the material is being tracked.
Right.
So every unit will be tracked when it leaves the factory until it comes back to the factory.
Who does that? The manufacturer?
Yeah, but they'll be reporting to, I think it's the IAEA.
Yeah, so this is part of the thing. This is still a bit under discussion. So depending on who licenses the application, that nation state is responsible for that nuclear material.
Right.
And they're responsible to the IAEA. The IAEA will probably have safeguarding tools on board, whether that's an electronic seal around the compartment or cameras to just monitor access. So they should have like 24/7 monitoring of the application, but it will be the nation state's responsibility to ensure that for the non-proliferation of that nuclear material, which leads on to other questions, but we'll maybe come there later.
Yeah, so basically everything will be monitored and tracked, and as with any new technology on like this on a yacht, that room is going to be so over monitored with sensors and everything else, because we need to make everyone feel safe.
Of course. I think that's interesting though, because again, going back to sort of a generic view, if you said to me yesterday we're going to put nuclear on a yacht, I'd think of, this great big thing in the middle of the boat that, but actually it's not, like you say, the crew are not going to be involved in it in the sense that they're not going to be touching it, they're not going to be near it.
No, it's not like Star Wars.
No.
Or Star Trek, sorry.
Star
Trek. Come on, Scotty, pull it. No, that does not happen. Now it's on a computer. That's it. You monitor the levels.
Yeah.
The system is very, very different. It's all about flows and heat transfer from the flow. So
and you said earlier about the safety cutoffs, that for it to be able to be put onto a boat, it has to prove that the technology is capable of shutting off at certain temperatures. So all the normal disasters that come into people's minds with the word nuclear, the technology has fail-safes in place to ensure that.
Yeah.
And the amount is obviously.
And the technology is such that it never gets to that pressure like we're talking about, high pressure pipelines and all sorts of stuff like that. So, and the biggest issue with these is cooling, right? So on our units, we would recommend, and the ones we've designed so far as concepts for people, is we double up on the cooling. So if the cooling flow looks like the seawater intake starts to get clogged up or something, there is another option.
Right.
There's another seawater intake. There's another sea chest. There's another area to flow to get the cooling in place.
Yeah.
So that, and then you can obviously service one while you keep it going. But if the cooling drops off, it will shut down to zero.
Yeah.
Now, what that means in practical terms right now is that if it goes to zero, the unit is finished,
Right.
and we have to take it off.
Okay.
Right? But what they've requested at the INL for during the testing phase in the next 6 months or so is, because it's a small 1 megawatt unit, can we restart it on the boat? Because it's the getting it going and stopping it are kind of like the two most dangerous parts,
Yeah.
if I'm correct, of any nuclear reactor. So if you can start this small unit on the boat, it's awesome for us as a yachting industry, or for maritime in general. You're going to dry dock, you can shut it down, stop it. Otherwise, you've got to create a different
safe
inlet
zone.
area for cooling water
Yeah.
and stuff like they do on subs. They have this big intake up high, so that before you dry out, you're already pumping lots of water in to cool off the system. If we can shut it down and restart it on board, we can shut down for refit for dry dock phases. We can shut down for, potentially time alongside if you wanted to go onto the local electricity, which obviously will be supplied by one of our units on land somewhere, so it won't matter so much. But, there's a lot of stuff we're still developing to try and make it a lot more user-friendly in the industry. So, and everything, obviously at that stage, everything's monitored.
Of course.
The engineer won't be doing that. We'll be bringing in a specialist to shut it down and ramp it up. There'll be someone specially trained, someone who's probably ex-Royal Navy or whatever.
But you're thinking about every eventuality, because actually I was going to ask about yard time.
Yeah.
But you've answered that by saying currently you're working to try and enable it to be able to be shut off but restarted.
Yeah.
Because, boats come out the yard and then a couple of years later they're refitted, or they're having warranty work done or something. So it needs to also, I guess, be convenient.
Yeah, and that's the thing. Or maybe what you'll do is you'll have an inlet up high, so that you can, if you're only in the yard for 2 weeks or a month or something, you'll just cool it down.
Yeah.
Because that's easy, and just drop the load right down to the lowest percentage. And then, because the rebooting it and stopping it is so inconvenient. But if you're going in for a 1 year or a 2 year full interior strip out and everything, that would be great to be able to shut it down to zero.
Yeah.
And let it just sit there waiting, and then boot it back up again.
Yeah.
So we are considering all those options at the moment.
It's very exciting. Jez, I'm back to you again. Sorry.
It's okay. That's what I'm here for.
Jez said at the start that you wanted to keep quiet, and now I'm throwing all these questions at you. So, as an ex-nuclear submariner, are you surprised how long it's taken for nuclear to come into the conversation of wider maritime and yachting industry?
Yeah, so I think, when you understand the technology, the capabilities, the opportunities it presents, it is a question as to why it's not made an appearance sooner. And I think there's a very good answer for that. Internationally, this was tried in the 60s. We had the NS Savannah, the Otto Hahn. So there were different applications of nuclear-powered commercial vessels in the 60s. But they were, as we discussed earlier, they were using pressurized water reactors. It was all a bit new at the time. Most countries didn't have nuclear power. There was only a handful of countries. So the assurances, the work to get port access globally was very difficult for countries like the US. They had to provide, hundreds of pages of documentary evidence and assurances and insurance to have the NS Savannah go global, which it did, but meant that economically it was not particularly viable. The SOLAS A491, the Nuclear Code of Safety for Merchant Ships, was written in the late 70s, incorporated in 1981. It's a non-mandatory document, but again is pressurized water reactor specific and for ships that have direct drive propulsion, which none of what we're looking for today.
It's a sort of different technology back then.
I guess what Derek was saying is we're looking to do things very differently. It's going to be almost certainly it's going to be a nuclear electric hybrid future. But then we looked at nuclear again in the 80s and then again in the early 2000s, around 2010. LR were working on nuclear rules for merchant ships as it was gaining traction as a viable option, but not for the reasons that we're looking at it today, which I think largely originally were for decarbonisation, but now as decarbonisation and energy security and independence. But obviously Fukushima happened around 2011. That sort of put paid to that as public confidence dropped significantly. So it's only really in light of decarbonisation and energy security and independence, that it's come back onto the agenda. And I think now is the first time that we've had that kind of national and international level sort of drive for these different alternate fuels that have given us the mechanisms to make the regulatory changes that we need to change to enable nuclear to be economically viable in maritime. Whereas previously it was by and large a commercial driver, and that doesn't really particularly resonate with governments to change regulatory requirements because such and such company wants to make more money.
Yeah.
So
I guess also as years go on and technology gets better, and the technology we're talking about now is very different to the technology that would have been used even in 2010, sort of shelving it because of public perception, because of an awful tragedy. But also things move on, don't they? And what we're talking about today is completely different safety wise. So I guess it makes sense to sort of pick it back up and think, actually, this is a different tool that we're talking about, and what the mistakes that were made in the past aren't necessarily relevant to even what concerns we'd have over this technology. So
safer is sort of so I think specifically from a UK perspective, the ONR have never licensed an unsafe application, for clarity. So all nuclear technology is safe at the point of licensing within the UK and other countries as well. Obviously, there's lessons to be learned, which we've learned from 3 Mile Island, Fukushima. Chernobyl's a bit of an outlier for a number of different reasons. But I think what the newer technologies, the Gen 4 technologies that we talk about, the way that they're positioned in terms of the advantages we've got in design and engineering, means that we can make them safer because we don't need to have active safety systems. So we don't need to have a pump to provide the cooling. They've been designed in such a way that they take passive sort of convectional cooling, that they are low pressure reactors rather than high pressure reactors. Therefore, we don't need to have an offsite emergency response organization because there's no conceivable way for that sort of contamination to spread into a wide area.
That have been learned from previous disasters have actually produced the product we're talking about today.
Yeah, 100%. They were all considered.
Yeah,
Definitely. Well, it's part of the next, as Jez said, Gen 4 is all about safety and learning from what's happened in the past. So.
But it's not just about safety and learning. So it's also about the sort of economics, that they are to be designed economically in a way that makes them more viable, that they are more sustainable because they have a higher burn-up rate of the fuel, such that we leave less waste to future generations to deal with.
But it is, I mean, you've got, as you said, you've already got pre-ordered 2,500 units. They are wanting to mass produce for land. And it's, again, goes back to that driver. There are other drivers in it that then appeals to the maritime world to jump on that wagon.
Yeah.
Because a lot of, they've got to put this in suburbia. It's going to be where your next Tesco's is going to be powered by a nuclear unit.
Or hospitals and all that stuff.
So it's got to be safe for land, and there's a kind of unified drive from all angles to really think about the technology before it's applied. And lessons learned.
But cost-wise, also, like you say, I mean, when you even think back 10, 15, 20 years ago, the cost to produce, the technology wouldn't have existed 20 years ago anyway to produce your unit. But also, like you said, previously when I'm not even going to say similar, but other products have been built, manufactured, designed, the cost would have been so out of reach for most councils, governments, industries, companies, individuals, whereas now it's becoming, I'm not going to say economic because I'm sure they're still expensive, but
I think the plan is that it will be economic, and for our units anyway.
With the energy that you can get back, like we're saying, if we're going into towns, villages, hospitals, when you think about how quickly you get the money back, then actually I suppose it is economical, especially with fuel shortages and.
But it has to be, right? Because if it's not, then
no one will buy it.
But it has to be in its own right. We can't have subsidies or bursaries. We've seen this with other sort of alternative fuels where governments have put sort of initiatives and subsidies in place to drive uptake. But what that actually means is if those bursaries and subsidies are taken away, then actually it's not particularly viable. Therefore, that either puts an onus on the government to continue to, support that, or industry will just walk away from it at a point later on in the future. And that's not what we want. We want to get to a point, arguably, holistically, this is about energy security, independence, and decarbonisation.
Sure.
So if we can't get there through, it being viable in its own right, but the bigger the uptake, the cheaper it will become.
Of course, yeah.
Yeah, I mean, they have deployable energy have right now a plant that can produce a gigawatt in a year, right? And that's thousands of units. Right next door, they have land to build another gigawatt factory. So as with anything, TV screens when they came out were hundreds of thousands of pounds. Now they're 200, 300 pounds.
Yeah.
This in time will become a lot cheaper as the production goes on and on. The uptake initially is going to cost more, but they're the people you need. You need people to spend that money up front. You need to get it all going. And I would see this dropping in price, and they might not like me saying it, but not in the long term. It'll be in the next 5 to 10 years. You'll see the price drops and more and more people. And I'd love to say to the guys, well, instead of just building it where you're building it now, why aren't we setting this up in Europe and the UK? And
where are they based? In the US?
Yeah, in Texas. So, and that's great. I mean, Trump has helped this industry massively in America. He has challenged people to get micro units up and running for July the 4th celebrations. And he has told, as far as I know, that anyone who's building an AI center or anything like that, there's going to be a drain on power, they have to provide their own power as part of that development. So that's going to massively help us and others.
Yeah, and I mean, the want for power is only going up, isn't it? So, okay, so this is a question a bit for all of you. So we've talked a lot about the pros, cons, and the actual product. What is the reality of seeing nuclear power on a yacht in the next 5 years?
Well, we have
just as a sort of timeline.
We have 2 vessels already that will have this on by 2029. Assuming all production goes ahead. They're not yachts, but they're vessels. And there are 3 other vessels that are humanitarian vessels that will also have this as part of their power system, and that's been posted on LinkedIn. Yeah. So it's these units, the ones that we're promoting, are going to be on board at sea by 2029, 2030.
So in the next 4 years, 4 or 5 years.
So there is no reason why that can't be put on a yacht.
Yeah. Because actually,
apart from public perception and apart from you might be restricted to what ports you can go to at the moment, we definitely have a challenging 3 years, 4 years of educating the public, and how we do that is something we need to seriously look at as a group, and that's why AJ Anderson has a couple of potential clients that we're working with him. Yes, Benoino, we're all collaborating together to try and spread the word and to start educating people, and we'll put together some plans with Lloyd's and a few others about how we, maybe increase that and start doing some stuff online, social media.
Well, I mean, you have to really now, don't you? Because if you have an owner who wants to build a big boat, we're 2026 now, you're looking at having those discussions now, because a big boat takes at least 3 or 4 years, maybe even longer sometimes to build. So actually, if we're thinking about releasing a boat within the next 5 years, this is the time to be
100%
making those decisions, isn't it?
Yeah.
So,
and we looked at right at the beginning. We looked at putting generators in and creating spaces, dedicated spaces where our Unity module, where a nuclear unit would go.
So you could sort of refit afterwards,
exactly.
put one in afterwards.
But the problem with that is you still have fuel tanks, and you still have large vent ducts, and you still have. And so, would you then put the nuclear units in and leave all of that in place?
It's a waste of space.
A waste of time. So it was one of the reasons we were delayed and held up. And now we're at the stage where you can actually design a boat expressly for this.
Yeah.
And in, like you said, 4 or 5 years' time, it'll be on boats.
Yeah. Thanks for watching this episode so far. We have some great guests coming up, and we wouldn't want you to miss any of those future episodes. So please don't forget to click the subscribe button and enjoy the rest of this episode. Okay, so going back to what we were saying about public perception educating, Ben, let's go to you. So what, a man on a mission, what conversations are you having now from a management point of view and build point of view with owners?
So again, we've got a number of owners that are interested in it. They're talking about, like Derek said, you kind of being ready for it. And I suppose the education, bizarrely, it's not the younger generation that you really need to educate. So if you go into schools and you go and see even universities and talk to them about it, they're like, yeah, but why aren't you doing it? Yeah,
Sure.
It's the green technology. It's environmentally friendly. It means that we can get product quicker. Why aren't you doing it? And then you come to our generation or older who hid under tables, or that's how they were taught when they were at school, because if something goes off. So it's an education of our generation that happens.
Yeah.
And there's loads of things. From a management side, people are like, well, how are you going to find qualified people? Well, as Derek said, it's a sealed unit. So your crew qualifications will generally stay as they are. But also we've changed education, and we've taught people or done courses. So like liquid hydrogen was a prime example, where there was no vessels that had done international voyages within liquid hydrogen.
Right.
And so they were like, right, you need to educate everyone. The crew need to be qualified. Oh my God, how's that going to happen? Actually, you get the experts to sit around a table, you find flag, we sat down with them and we produced a course. The course was different. So everyone on board had to be trained. So it's not just the engineers anymore. And a lot of that was awareness. So I imagine something similar will happen, that you will have an awareness program that's run by the management company on the crew training that explains what is on board. For liquid hydrogen, it was explaining to people how it works. So everyone from the deckhand up to the captain had to go on do a certain level of courses. But that course was created, it was put into place. And as Jez said, IMO and others react when reality hits. So that course foundation is now being used in IMO to help create the foundations of liquid hydrogen training for maritime, because it was a necessity that needed to happen. So all of this is just about, educating, talking to people, and, us also managing the expectation of owners. The thing is, owners, are human beings, and actually a lot of them, their children are young enough to be children, that they want to drive the newer technology. And as you saw with the liquid hydrogen boat, and as you will see with a nuclear boat, someone will go, well, we need to show that the concept is safe. Derek had the owner, it's then bringing everything along on the journey. So there are, if we need to have nuclear experts on board, there are an awful lot of ex-Royal Navy nuclear engineers and others. Again, you just bring them into the industry. You may have to yachtify them slightly.
Sure. But the concept's
but the concept's there. The safety element, the reality. And actually, the industry has matured, even in our 25 years I've been doing it. It's grown up. So the risk assessments, the ALARP processes, the industry are used to doing that on the bigger yachts, and even some of the smaller yachts now. The flags are more engaged, the class are more engaged in assisting in that process. So you just need the right people in the room to drive it forward.
Yeah, which it sounds like already that is the case, because it sounds like all the elements you're covering, you've got the technology, you've got operational, and then you've got the safety and compliance element. And it sounds like everyone involved not only knows what they're talking about, but really wants to bring it to the industry because of all the positives we've talked about today. So from an outside point of view, when you're talking about educating people, you're covering every base. And I know, Derek, you did a tour of a lot of the major yards and sat and answered probably a lot of the questions I've asked today, to try and educate in that way. And like you say, the new generation of people coming into the industry probably is coming in with a much more positive mindset to wanting to bring sustainable alternatives in, and probably can't understand why we haven't already.
Well, I had the classic at the design forum in Kitzbühel with Boat International. I gave a presentation on the nuclear side. And just before it, my daughter messaged me and said, how's it going? You ready for this? And I said, well, there's 460 people in a room. Probably half of them don't agree with what we're talking about. So, it could be an interesting 20 minutes or so. And she just wrote back and said, and she's Gen Z, right? She wrote back and just said, well, just tell them everything else is worse.
She should be your head of marketing.
But I think,
She should be your head of marketing.
I think actually from an operational point of view, it is a safer technology than other fuel types that are being banded around, that are reality, that are coming online in the next year or so. It is a safer product to actually work with on board.
Yeah.
You know, you haven't got the complexities of bunkering and trying to bunker liquid up.
I was going to say,
Interesting.
just sorry to interrupt you, but actually, when you think about it, because nuclear has this sort of slightly, I don't want to say negative, but I guess it's sort of uneducated. We don't really understand it, so everyone's a bit frightened of it. But think of all the terrible things that do happen on yachts safety-wise anyway, to do with other materials that are being used. It's not as if we're sitting in an industry where a boat is 100% proof of fires and explosion. I mean, I don't want to obviously tempt fate, touch wood, it doesn't happen to anyone, but you know what I mean. We're not sitting in this ivory tower of yachting's completely safe and this isn't. So actually, when people are talking about it being unsafe, when you break it down, it's no more unsafe than things already utilized. And like you say, you're
a lot safer.
You have a diesel engine that you don't put in a box, you don't know, but it can still have a runaway.
And if it's
when
not
it has a runaway, it explodes.
If it's not maintained correctly, there are things that can go wrong. Whereas actually with this technology, once it's in and it's sealed and no one tampers with it, which is all the things you're talking about putting in place, the room for error is a lot less because there's no humans involved, which often, let's face it, on a boat can be a cause of some not great situations.
And I think
it's awesome. I think you're converted. Oh, yeah. It's the way to go. Well done,
I want
Alicia.
commission for any that are sold.
But it's, and again, but also everyone that comes to the party is aware that technology is on board. So when you look at the new fuels, everyone from the owner downwards is aware that technology is on board. So the professionalism that then goes with that is part of it. So, you know, when these vessels come online and are in build, the industry will know about it. You know, as much as we're the top secret world it is, reality will be people will know and crew will know.
Yeah.
And, you know, again, it will be educating crew as they come on board, the professionalism that will need to be there. And so we've seen it with the newer technologies that actually that kind of commercial shipping background, and that you're almost a step up in the professionalism of people on board, because all it is just awareness of what you're dealing with.
Yeah, sure.
And it will be, and is from an operational point of view, it is a safer product.
Yeah.
That'll be the bit to get across, isn't it? Because when you think about, you start crewing up a year out from delivery, and you've got to interview the crew member and just say, hey, by the way, do you want to join this boat? Yes, it looks like it's awesome. And we're nuclear powered. Oh. So hopefully we would have educated everyone by that stage.
But then
so we've
also
got a bit to do.
The generation of crew coming through
Gen Z.
Yeah, you're not probably trying to convert a 65 or a 55-year-old person. So actually, and I think it's like anything, when it becomes more mainstream, when it's more commonly talked about, which is exactly why I wanted to have this conversation, it becomes less frightening and less, you know, sort of something that people talk about but you don't really understand. I think once it's on TikTok, you'll be fine.
Yeah.
So.
Yeah. But it is for educating the crew. It will be things like the shielding around the unit.
Yeah.
You know, so that, as we were joking about before, that they don't turn bright yellow because they're sleeping next to the reactor.
Yeah.
And now all of that is like, you know, the amount of shielding that's in place around the unit, the protection that's there. You as crew, whether, you know, if your interior, your deck, even, you know, the office, they're not going to know it exists.
Yeah.
Apart from the vessel is quieter and it goes quicker and they don't have to keep going to port to bunker fuel.
Yeah.
So it's again, it will just be an education program and things like this, and doing more talks and getting people, as we've both been in various conferences where there's a lot of negativity about it.
I'm sure.
Which I get, you know, they're always apprehensive about new technology or seeing what reality is. And just there's huge amounts of challenges still to kind of iron out, but everyone knows what they are.
Yeah.
So it's a process rather than a challenge of getting to that end goal.
Yeah.
And that negativity, if you consider it, is always with the older guys. It's not the younger one.
Yeah.
So yeah, it's
Okay, well, that actually brings me on to my final question. This one is for all of you. You can all give me your sort of idea. What is the biggest misconception about nuclear and yachting you'd like to change? Jez, I'm going to start with you.
The biggest misconception of nuclear in yachting or for yachting?
When or both, when we talk about the idea of having nuclear powered vessels.
Right, so probably it's going to go back to the safety of nuclear, and safety is a bit of an interesting play, because I think it depends on how we're defining safety as to what safe it is, because you won't have a technology to integrate into a yacht unless it's been proven to the nuclear regulator that it's safe to do so.
Right.
And then in the integration and commissioning, we'll have to produce a safety case to show that it's safe for the integration. So it will be demonstrably safe. I think the technology, historically, by design, it is the safest energy production form. If you take away the attributed deaths from Fukushima, which were nothing to do with nuclear and more to do with the evacuation, the disputed evacuation from the area, actually nuclear per terawatt hour is safer than wind and solar. So it's the safest, or one of the safest energy production forms we have. But even in the event of an accident, Fukushima, 0 attributable deaths because of the radiation. So high levels of radiation causing acute radiation sickness, like we saw at Chernobyl, from people that were put on the ground incorrectly to clean up material that they should never have been there.
Yeah,
you're just not going to see that kind of accident and that kind of sort of scenario where you could see that kind of immediate sort of consequential safety concerns around some of the other alternate fuels. We know about the toxicity of ammonia, for example. I think the questions around nuclear tend to be more long-term, sort of would an increased level of radiation, is it attributable to fatal cancers? And that's largely where the whole industry has had a bit of a problem for decades, is it becomes very difficult over a longer period of time to demonstrate whether somebody that gets a fatal cancer is attributable to a slightly higher level of radiation dose over a longer period of time, or whether they would have got that anyway.
Yeah.
I think there's building evidence, and has been for a long time now, that actually the linear no threshold model that we have for radiation, which says that radiation at all levels is bad, which drives the regulatory response that we have, which is you must make it safe unless you can demonstrate that it's disproportionately for time, effort, and cost to do so. That drives that response. Whereas if we could show that low levels of radiation to a point are safe, which I think there's evidence to suggest that it is, then that changes the whole regulatory approach and the whole way that we have to manage nuclear applications. Because you could say radiation to this point, we don't have to do anything. We don't have to put additional shielding. We don't have to put additional control measures in.
But the product we're talking about to potentially go on to yachts, the shielding is built in anyway. So any crew working on the boat would not be exposed to any more radiation than they would be if they worked on a boat.
Almost certainly you will. So I spent decades on nuclear submarines, and my outside of specific maintenance activities, my dose rate would be lower than most people in the general public.
Yeah, I mean,
because
flying
of the shielding,
on
planes,
all
CT
sorts of things.
scans.
So I think that's going back to the misconception then. So what you're saying is that the levels of radiation that we would all worry about when we hear the word nuclear would not actually be relevant if you worked on a vessel that was nuclear powered, because you would be no more exposed to radiation than you would if you worked on a boat that was powered by diesel engines.
Yeah.
Okay.
Yeah, I had a regulator made a comment, I won't say who it was, about the fact that an engineer would probably have less radiation exposure on one of these boats than a pilot on a 6-hour flight.
Really?
So, and we don't worry about the pilot. Well,
No,
we
sure.
obviously always worry about the pilot, but but we're not concerned about his radiation exposure.
Of course,
So,
yeah. So I think that's an important one though to say, because I could imagine when people, for instance, we talk about crew, they'd be like, oh, I don't want to work on a boat that's nuclear because I might want to have kids, or I don't want to end up with cancer or whatever.
Go back to these old
exactly, but that's what I'm saying. These misconceptions, which are very outdated now, but actually it is just general consensus. What about you, Ben? What would be your misconception you would like to?
I just think that it's an opportunity for yachting, especially, to kind of lead the industry. So it's properly green energy. So rather than, all the greenwashing and all the other bits that kind of get banded around maritime, not just yachting, it is an opportunity to have green energy, and it's opportunity to then lead that technology. And I think, it's also just educating and changing the misconception of, oh, well, even that egg cup of nuclear waste, that's really bad. And if 1,000 vessels have that, that's a lot of egg cups. Yes, but then there's also technology about that. Even that bit of waste is already being utilized to look at powering space flight. It's looking at all kinds of stuff. So actually, the amount of waste is even less than the preconception is of that. And it's an opportunity for the industry to kind of show its maturity and help drive it forward. And I think that's a big thing that's changed, is that actually our industry is at a mature state where people are talking to the regulators much earlier. Whereas before, the rule would come and hit you in the face and then you'd figure out how to deal with it. More and more now, you're seeing the industry proactively approach IMO and others to be like, look, we do this. Yeah. We think this is safe. And it's just more talks like this, more explaining the possibilities, accepting the challenges, accepting that, but also making sure that the criticism is countered with the positivities, because I do think the positivities outweigh the negatives.
Yeah. No, I think, and something you touched on then about green energy also. I mean, realistically, if we, like you mentioned, Jez, if we do want to do something about the climate state that we're in, these conversations, it's a sort of a trade-off, isn't it? There's risks with everything. There's risks with any fuel that you're going to use. But what are we trying to achieve? Are we, with diesel, there's all sorts of downsides with that, with pollution and costs and transport and everything. So it's sort of finding the best solution for the situation we're in. And if safety is the main concern for most people, because we've talked about cost and how actually the cost is not perhaps what people might think, and as time goes on, it's definitely going to come down. What would be the next concern? It's safety. Well, we've talked about that. And actually then the rest sound like pros. I'm sure there are other...
Well, it's got to be a health, doesn't it? I mean, we're all sitting here sucking in noxious gases from diesel engines and diesel yachts, and if you can smell the exhaust from the generator, it means you're sucking in something. So you won't have that.
And also the environmental impact on the oceans, and which without oceans we don't have boats, do we? Yep. Right, Derek, finish up then. Tell me what your biggest we might have covered it already, but after doing your tour, for instance, what was the biggest misconception that you sort of happily...
Well, it was interesting doing the tour because obviously we visited 6 shipyards, large shipyards in Northern Europe. And most of the crowd participants were engineers.
Right.
So at the end of it, they weren't just interested in what we were going to provide them for yachting. They were interested in how we were going to help them as a shipyard.
Interesting.
And so the uptake there is, okay, how do we get this in the shipyard first?
Yeah.
To cut down our operational costs, and then look at how we can put it on boats.
Yeah.
And
that's interesting then. So the shipyards then sort of flipped it slightly, and then they're looking at using the technology to energy secure their factories.
Yep.
Maybe potentially save money in the future, employ more staff, or have the security of having money to pay their staff. They're perhaps reducing costs of building boats, which are rising constantly.
Potentially, yeah.
Before even putting it on a vessel.
Yeah,
exactly. That's interesting.
Yeah.
Well, there's huge pressure, isn't there, on shipyards to be more environmentally friendly in the manufacturing process.
Yeah.
And, the energy it takes to build these boats, as we all know, is massive. So, I mean, most shipyards you go to in Northern Europe now are, they've got their solar panels, they've got their heat generation.
Much,
They've got their heat generating systems to try and
There's limitations, of course, though. I mean, you can try all those things, but actually to produce a vessel that we're talking about in one of the big shipyards, of course, there's going to be cost environmentally as well as financially. So that's really interesting that they're thinking that way
Well, it comes back to the whole thing of, do we think there'll be one power for yachts? The shipyards are the same.
Yeah.
There won't be one power for them. We'll have a Unity module sitting alongside solar panels and heat source and everything else, and they'll use the package to balance out, and they'll still be using local electricity, but hopefully not as much.
Interesting. Oh, well, thank you so much, guys. That was very interesting. I'm a convert. And I think we covered a lot of points that I had in my notes, which I know for sure many other people, when the conversations come up over the dinner table or an event or something, people have mentioned to me. I tried to write them down. So I appreciate everyone's time and their expertise. Thanks, Jez.
No worries. Pleasure.
Thanks, Ben.
Pleasure.
Thank you, Derek.
Pleasure.
That's brilliant.
Yeah, so now people can call you instead of us.
Excellent. Well, thanks so much, guys.
All right.